All right, this video goes over the three measures of central tendency. A measure of central tendency is basically one number that will represent a bunch of different numbers. So here we have an example of four different numbers, 8, 14, 10, and 8. The first measure of central tendency we'll go over is the mean. The mean is also known as the average. We more commonly say average, although like mathematically it's called the mean. To calculate the mean or the average, we add up all the numbers, also known as finding the sum of all the numbers, and then we divide it by how many numbers there were in the data set, or the number of numbers. So to calculate the mean here, we would add up our numbers, which is 8 plus 14 plus 10 plus 8, or find the sum of these four numbers. Then we would divide by 4 because there's a total of 4 numbers. These four numbers add up to 40, and then we divide by 4. So we know our mean is 10. Besides mean, the second measure of central tendency is the median. The median is the middle number. But very important, the first step to finding the median is the middle number when they're in number order. So you have to put the numbers in order. And if your data set has an odd set of numbers, let's say it has 3, 5, 7, 9 numbers, then there's exactly one middle number. Then the median is really easy to calculate. If your data set like this one has 4 numbers, right? That's even. 4 is an even set of numbers. Then there are 2 middle numbers. And it's a little more complicated with 2 middle numbers. You have to find their average. So here's how you would find the median for this data set. Again, first step, put them in number order. Right, so we have 8, 8, 10, and 14. Then I'm going to cross out the smallest and the largest until I have 1 or 2 middle numbers. Here I have 2 middle numbers left. So I need to find their average. 8 plus 10 divided by 2, because again, finding the average or finding the mean. Add up the two numbers, divide by how many? There are 2 of them. So 8 plus 10 is 16 divided by 2. So our median here is 8. Lastly, we have the mode, the third measure of central tendency. The mode is the easiest to do, but it can also be the trickiest on a quiz or a test. It's the easiest because it's the most frequent number, right? So we look which number appears more than the other ones. Obviously, 8 appears twice, while 10 and 14 only appear once. So in this example, our mode is equal to 8. Now, sometimes it can be tricky, right? If every number in your dataset appears once, then no number appears more than the other. So then you would say there's no mode. And then sometimes, like for example, you have 1, 1, 2, 3, 4, 4. I have both 1 and 4 appearing twice. Then they're tied to be the mode. So there are multiple modes. So in this example, the modes would be 1 and 4. You don't find the average. You just say there are 2 modes, 1 and 4. But for our example, the mode is 8. So these are the basic ways to find the measures of central tendency, or the 3 measures. Next up, I want to introduce a concept called outlier. So I'm going to take the same data set, except now I'm going to add another number. Let's say I added an 80 to it. Now, obviously 80 is very different from 8, 14, 10, and 8, right? 80 is a lot bigger. Any numbers that's too big or too small compared to the rest, that's called an outlier. An outlier is too big or too small. And as you'll see shortly, having an outlier will mess up one of the 3 measures of central tendency. Let's calculate. If we were to calculate the mean again, I knew that 4 numbers added up to 40 earlier, so I just have to add the 5th number, 80, to find the total sum. And instead of dividing by 4, because there were 4 numbers, now I'm going to divide by 5, because now there's 5 numbers. That's 120 divided by 5. I'm going to do my arithmetic. 120 divided by 5. 5 goes into 12 2 times. 2 times 5 is 10. I subtract. I get 2. Bring down the 0. 5 goes into 24 times exactly. So my mean is now 24. Compare that with earlier, my mean was 10, right? 10 is a good representation of these 4 numbers because these 4 numbers are all pretty close to 10. 24 is no longer a good representation of these 5 numbers, right? None of these 5 numbers are close to 24. So the mean is no good, right? The mean had a delta, or a triangle means delta, or a change of 14, right? It went from 10 all the way to 24. The mean increased by 14. That's not good. It's no longer a good measure of central tendency. Now let's look at median. For median, I have to, again, first step, always put things in number order. So I have 8, 8, 10, 14, and 80. I have 5 numbers now. With 5 numbers, that is an odd set of numbers, which means there's exactly one middle number. So it's actually easier to find the median now. So I cross out the smallest, largest, largest, and I end up with a median of 10. My median before was 8, and now it's 10. So the median did go up, but not as much, right? It went up only by 2, a delta of 2. And I would argue that 10 is still a good representation of your number, right? 10 is a good representation of, well, it's a good representation of 4 of these numbers. So 10 is still pretty good. Lastly, we have the mode. From these 5 numbers, the mode, the number that appears more than the others, is still 8. 8 appears twice. So the mode didn't change. Except generally we just don't use the mode. We use either mean or median. So the key point I want you to remember is that if there is an outlier in your data, the mean is no longer a good representation. Right? This 24 right here does not represent your data anymore. So with an outlier, do not use the mean. Right? Generally, median is always a safe bet. Median always works. If there's no outlier, if this didn't exist, then all 3 measures of central tendency work. If there is an outlier, the mean is better. The median is better than the mean. All right, let's do an example problem here. In Bill's science classes, quizzes are graded on a scale of 0 to 10. The list shows Bill's scores on 10 quizzes. Let's see, are there 10? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, there's 10 numbers here. Bill wants to convince his teacher that he deserves an A. Should he use the mean, median, or mode to describe the data? Why? So let's calculate them. To find the mean, I need to have the sum. So 6 plus 7 is 13. 10 plus 9 is 19. 9 plus 5 is 14. 7 plus 9 is 16. 8 plus 6 is 14. So I added pairs, and then now I have 5 pairs. I'm going to add them up again. 3 plus 9 is 12. 22, 26. 2, 3, 4, 5, 6, 7. So the sum is 76, and I'm going to divide that by 10 because there were 10 numbers. So I get a mean of 7.6. To find the median, I have to put them in number order. So the smallest one is 5, then there's 2 6s, then there's 2 7s, there's 1 8, 3 9s, and 1 10. Let's see, 1 2 3 4 5 6 7 8 9 10. Good, I'm not missing anything. 10 numbers, that's even, so there are 2 middle numbers, right? Small, big, small, big, small, big. I'm left with two middle numbers. So I need to find their average. So 7 plus 8 is equal to 15, and the 15 divided by 2, because I have to find their average, which is 7.5. So mean is 7.6, median is 7.5. Mode. Well, mode is easy, right? 6 appears twice, 7 appears twice, but 9 appears 3 times, more than any other number, so the mode is 9. He wants to convince the teacher he deserves an A, so he wants the highest grade. Out of these three, the highest grade is the mode. So he's obviously going to say, use the mode to calculate, to represent his data. All right, good luck on your practice.